Okay. Is my screen visible?
Yes, sir.
All right.
Yes.
Let us.
Yes, sir.
Thank you. Let us quickly recall what we have seen in morning. So we have started with the partial derivative, which is applicable to two variable function or more than two variable function. Of course, it is applicable to one variable function, but in that case, it will be called as ordinary derivative. Okay. So we looked at a definition of partial derivative. Uh, while calculating partial derivative with respect to x, uh, we are treating y constant. Okay, and a definition from calculus is limit delta x tends to 0 f of x plus delta x comma y minus f of x y upon delta x. On similar line, you can define uh, partial derivative with respect to y and other variable. Okay, and more general, if function of uh, n variables or more than n variables is there, still you can find its partial derivative with respect to any variable, treating other variables constant. Okay. Then we looked at physical representation or graphical representation of this partial derivative, and then we were studying this example to find out partial derivative of first order and then higher order. Okay, or mixed partial derivative. So fxx, fxy, then fyy. Okay, so this derivative we have seen in morning, and then we observed that uh, fxy and fyx are same. Okay, so and it is same for continuous function whose first order partial derivatives are also continuous. Then we consider this problem: u is equal to x square tan inverse y by x minus y square tan inverse x by y to find out u xy. Okay, and how did we calculate it? So you first of all find out partial derivative of u with respect to y, and then you differentiate that whole function with respect to x again. So w by y, after calculating, it was x minus 2y tan inverse x by y. Then you differentiate it with respect to x. We got it as x square minus y square upon x square plus y square. Okay, and then we were about to start this example. Fine, can we start?
Yes, sir.
All right. So u is equal to x raised to y. Then we are asked to verify dabba to u by dabba x dabba y equal to dabba to u by dabba y dabba x. So u is x raised to y. So with respect to x, first is with respect to x, this y is treated as a constant. So it will be something like x raised to n. So whose derivative is n into x raised to n minus 1. Okay. So that is w by w x is equal to y x raised to y minus 1 because y is constant. Again, this is not required. W to u by w x2 is not required. Then with respect to y, you differentiate this w by w x. Okay. So w by w y of w by w x. So substitute w by w x. So w by w y of y into x raised to y minus 1. Okay. Now this is function of y. X raised to y minus 1 also contains y. So you need to apply product rule. Okay. Now note that you are differentiating with respect to y. So x is a constant. So it is looking like a raised to y minus 1. So what is the derivative of a raised to y?
A raised to y log a.
A raised to I log A.
Yeah, good, good. So let us differentiate it with respect to y and apply product rule. So y as it is, a derivative of x raised to y minus 1 with respect to y is x raised to y minus 1 into log x, because x is constant, plus x raised to y minus 1 as it is, derivative of y is 1. Is this step clear to everyone? Yes?
Yes, sir.
Okay. Then we have got this daba to u by daba y, daba x. Now we need to calculate daba to u upon daba x, daba y. So u is equal to x raised to y. You differentiate it with respect to y first. Okay. So with respect to y, x is a constant. Okay. So x is something like a. So derivative of a raised to y with respect to y is again a raised to y log a. So w by y is equal to x raised to y log x, because x is constant. Now you differentiate it with respect to x. So daba to u by daba x daba y is equal to daba by daba x of daba u by daba y. So daba by daba x of x raised to y into log x. Now again, x raised to y contains x and log x is another function of x. So you will have to apply product rule. So x raised to y as it is, derivative of log x with respect to x is 1 by x, plus log x as it is, derivative of x raised to y, where y is constant, is y into x raised to y minus 1. Okay. Now if you simplify this, it will be x raised to y minus 1 plus y into x raised to y minus 1 into log x. Okay. So if you observe these two things, daba 2u by daba y daba x and daba 2u by daba x daba y, they are same. Okay. Understood?
Yes, sir.
Okay. So just note it down, because such questions can be asked of verification. So let me scroll it, copy it fast. Finished?
Yes, sir.
Yes.
Okay, fine. So let us go ahead. So if v is a function x square minus y square into f of xy, where xy is in multiplication, then show that vxx plus vyy is equal to x raised to 4 minus y raised to 4 into f double dash of xy. Okay, so let us do it quickly, or do you want to try? It's up to you. I can give you time, or I'll explain here. Anyway, you are not.
So we'll try then.
Okay, what about others?
So I'll
Yes,
try.
sir.
All right, so
Yes, sir.
fine. So try it for 5 minutes and then we'll go ahead.
So can you scroll to the question statement?
All right. Done?
Yes, sir.
Done, sir.
Got it? Arey, good.
Yes, sir.
What about others? Okay, let me go to the solution. You can check yours. So Vxx means the derivative of V uh, with respect to x twice. Okay, and similarly Vyy means the derivative of V with respect to y twice. So let us find out first derivative dabba V by dabba x. So you can see that this x square minus y square contains x, f of xy also contains x. So you need to apply product rule. Okay, so fxy as it is, derivative of x square minus y square with respect to x partially, which is 2x, plus x square minus y square as it is, derivative of f of xy is f dash xy because that function is not known. So f dash xy into derivative of this inside product with respect to x. What is it? What is it? It is y. Is it fine?
So that
Yes?
function f of xy could be any function of
Yeah.
x and y, right?
Yeah,
So
yeah,
how
xy
do
in
we know that only y is going to come out?
No, no, no. See, xy is in multiplication. It is not
So,
x comma y.
okay, okay, right. Huh. Okay.
So f dash xy into derivative of xy with respect to x. So that is y. Is this step clear? First step.
Yes, sir.
Yes, sir.
Then you differentiate with respect to x again. Okay. Now you can see that again you will have to apply product rule. So f of xy as it is, derivative of 2x with respect to x is 2, plus 2x as it is, derivative of f of xy with respect to x is f dash xy into derivative of xy with respect to x is y, because y is constant, x ka derivative is 1. Now plus here also there is a product of function. So y as it is because it is a constant. So apply product rule for these two functions x square minus y square into f dash xy. So f dash xy as it is, derivative of x square minus y square with respect to x is 2x, plus x square minus y square as it is, derivative of f dash xy is f double dash xy into derivative of xy is y. Okay. Now if you simplify this, you will get 2 into f of xy plus this second term is 2xy into f dash xy, plus if you multiply this y inside the bracket, then 2xy f dash xy plus x square minus y square f double dash xy y square. Up to this step, any doubt?
No,
No,
sir.
sir.
No.
Okay, okay, fine. So one side is, or one thing is calculated already. So v y y. So let us find out derivative of v with respect to y. So again apply product rule. F of xy as it is, derivative of x square minus y square with respect to y is minus 2y, plus x square minus y square as it is, derivative of f of xy is f dash xy, and then derivative of xy with respect to y. So that is x. Okay. Now you differentiate this one more time with respect to y. So again product rule. So f of xy as it is, derivative of minus 2y with respect to y is minus 2. Again, then minus 2y as it is, derivative of f of xy with respect to y is f dash xy into x. Okay, because derivative of xy with respect to y is x, plus this x as it is, apply product rule for these two functions. So minus 2y into f dash xy plus x square minus y square as it is. Derivative of f dash xy is f double dash xy into x. Okay, so you just simplify it. Minus 2 f of xy minus 2xy f dash xy. You multiply by x inside the bracket. So minus 2xy f dash xy plus x into x becomes x square minus y square f double dash xy. Now if you add them, if you add 1 and 2, this 2 f of xy minus 2 f of xy gets cancelled. 2xy f dash xy minus 2 f dash 2xy f dash xy gets cancelled. Then 2xy f dash xy, this is minus 2xy f dash xy gets cancelled. And here x square minus y square f double dash xy is common in both terms. So x square into f double dash xy into bracket x square plus y square. Okay. So this is x square plus y square, another bracket x square minus y square, which is nothing but x raised to 4 minus y raised to 4. And this f double dash xy as it is. Is that fine?
Yes, sir.
Yes, sir.
Yes, sir.
All right.
Sir, the function f of x,
Uh,
when we will differentiate it with x, we'll get f dash xy.
right.
And but when we will differentiate it with respect to y, will
Uh,
we get the same f dash xy?
okay, let me tell you. For time being, you write down that xy as z. Okay, for time being, you write down xy. This xy is in multiplication. You write it as z.
Okay,
Now,
sir.
yeah, now you differentiate it with respect to z, with respect to x. Apply rule of composite function. What is it? df by dx into derivative of this inside function with respect to x. So the df by dz, we are denoting it by dash, f dash.
Uh, yes, sir. Okay, I got it.
Yeah, fine. Any other doubt? Others?
Sir, I had the same doubt as him,
1
and you
minute, sir.
said after writing xy as z,
Uh,
then what did you say again?
now you differentiate it with respect to x. This is f of z. Okay. Now
Yes.
you differentiate f of z with respect to x.
Okay.
What it will be? df by dz into double
Into
dz by
dz by
dx,
dA. Right, huh? So
isn't
the
it?
first thing is common to both.
Yeah. So
Okay.
is that fine now?
So, but if we say xy is equal to z, then won't we have to substitute the same thing in x square minus y square also?
No, 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 no. This is completely different than this function. This is, can you tell me one example of f of xy? See, this is not f x comma y. So let me tell you example 1 plus x square y square plus x raised to 4 y raised to 4. So whenever there is xy, it will be with same power. Okay, and this x
Sir,
square minus y
sir,
is a different function.
okay, sir. Okay.
Okay, yeah. I mean hereby when you write f of x into y, there won't be some function like x square y. It is not of the type f of xy. Okay, x and y will come together. Even if it is power, it will have same power to x and y.
Okay, sir.
Okay. Do you copy?
Yes, sir, done.
Alright, fine. Uh, Let us quickly go to this problem, but I think it's very easy. Let us do it. So u is equal to x raised to m y raised to n. Then show that dabba 3u upon dabba x dabba y dabba x is same as dabba 3u upon dabba y dabba x 2. So first of all, tell me a difference between these two notations. What do you mean by dabba 3u by dabba x dabba y dabba x? Yes, anybody?
Sir, the order is different.
Okay, so in this derivation or differentiation, you are going to differentiate it with respect to x first, then y, and then x. Is this fine?
Yes, sir.
Whereas in this dabba 3u by dabba y dabba x2, you are going to differentiate with respect to x, then with respect to x again, and at the end with respect to y. Understood?
Yes, sir.
Yes, sir.
Okay,
Yes.
so let us go to the solution. So let us find out left hand side first of all. So u is x raised to m y raised to n. So differentiate it with respect to x. Y will be constant. So m x raised to m minus 1 y raised to n. Then you differentiate this thing with respect to y. So m x raised to m minus 1 is constant. Differentiation of y raised to n, that is n y raised to n minus 1. Okay? All right?
Yes, sir.
And
Yes, sir.
at the end you differentiate this thing with respect to x. So y is constant, so m and n y raised to n minus 1 as it is. Differentiation of x raised to m minus 1 is m minus 1 x raised to m minus 2. All right, so this is one side, m into n into m minus 1 x raised to m minus 2 y raised to n minus 1. Fine.
Yes, sir.
Now let us calculate this side. So find out dabba u by dabba x, which is already calculated. Dabba u by dabba x is m into x raised to m minus 1 y raised to n. Then again differentiation with respect to x. So y will be constant. So m y raised to n as it is. Differentiation of x raised to m minus 1, which is m minus 1 x raised to m minus 2. All right. Now lastly with respect to y. So differentiate this thing with respect to y. So m minus 1 x raised to m minus 2 are constants. So m minus 1 x raised to m minus 2 are constants, and derivative of y raised to n is n y raised to n minus 1. Now you can check that both these things are same. All right. So note it down.
Sir, with this example, is there a theorem behind this now?
No, for second degree or second order derivative, that is there is a theorem.
Okay.
Okay, as we discussed in morning. Copy. Can you go ahead?
Yes, sir.
Yes, sir. Yes, sir.
Fine. So next is chain rule for composite function, and there are different chain rules. So this is first case. Okay. So if u is function of r and r is function of xy, if u is function of r and r is function of xy, then you can calculate derivative of u with respect to x, and that will be obviously partial derivative. Okay, because ultimately u is function of two variable. Okay, indirectly. So dabba u by dabba x, and how do you calculate it? You differentiate u with respect to r. Now this is ordinary derivative. Okay, du by dr, and then r with respect to x. Similarly, you can differentiate u with respect to y partially, and what is it? Dabba u by dabba y is equal to du by dr into dabba r by dabba y. Okay, understood? So you can consider this tree diagram as well. So u is function of r and r is function of xy. This middle thing is r. Okay, which is quite blur, but this is r. R is function of x and y. So dabba u by dabba x is u with respect to r into r with respect to x, and here dabba u by dabba y is u with respect to r and then r with respect to y. Understood? Chain rule?
Yes, sir. So, but while differentiating, we'll
Yes,
not be able to
sir.
differentiate with two variables, right?
No,
With respect to
not.
two variables, du
Okay,
by
let me
dr.
give you let me give you example. U is equal to r raised to m, where r is x square minus y square plus z.
Okay, so we'll not substitute in the first place.
No, no, no. Let us apply chain rule, and that will be more easier to for calculation purpose.
Okay, sir.
Okay. So just note down these two formulae, and title is chain rule for composite function first case. And
So 1 minute, 1 minute.
yeah. Somebody kept his or her mic on. Please mute yourself so that there won't be noise. Can you go ahead?
Yes, sir.
All right, fine. Let us just look at this second point and then probably we'll stop. Okay, let us just discuss this second case of chain rule, which is important. So u is function of xy. Anyway, there is notation z. So z is function of xy, and xy are functions of s and t. Okay, so here is the tree diagram. Z is function of xy, and x and y are functions of s and t. Okay, so let me say something like z is equal to x square minus y square, where x is equal to s square by t and y is e raised to st, something like this. Okay, in that case you can calculate partial derivative of z with respect to s as well as z with respect to t. Z is function of xy, xy are functions of s and t. So rule is dabba z by dabba s. Okay, dabba z by dabba s is equal to z with respect to x, that is dabba z by dabba x, into x with respect to s, plus z with respect to y, then y with respect to s. Note that this s is common, s, s and s. Okay, there is no role of t while differentiating with respect to s. And then dabba z by dabba t is z with respect to x, then x with respect to t, plus z with respect to y, and then y with respect to t. Similarly, you can write this chain rule using uh, this tree diagram. So z to s, you want to come from z to s. So how many ways are there? How many ways are there to come from z to s?
Two
Two
ways.
ways. Okay, so z to s, this is first way, and then z to s, this is second way. All right, so z with respect to x, then x with respect to s, plus add this way, z with respect to y, y with respect to s. All right, and again z with respect to t, there are two ways. Okay, this way and then from this side also. So z with respect to x, x with respect to t, plus z with respect to y, y with respect to t. Do you understood this chain rule?
Yes, sir.
Yes, sir.
All right. Any doubt in this? Please understand this, because next time example will be based on this chain rules. Just note down and then we'll stop. Before leaving, just write down your name and roll number in chat box. This tree diagram is important, so sketch it or draw it in your notebook and then write down these two partial derivatives.
Sir, if we are done, can we leave?
Have you copied?
Yes, sir. I've
Okay.
written it.
Yeah. You have marked your attendance?
Yes, sir.
All right. All right.
Yes.
Then you can leave.
Thank you, sir.
Yes.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Excuse me, sir.
Yes.
Sir, you in this example about two examples back, sir, where there was f of x y, you
Huh.
were so when we differentiate that with respect to x and with respect to y, both times we write f dash of x y instead of.
Yeah. Yeah.
So
Yeah. Here,
you said
here, this rule is
yes, sir.
applicable there. This rule is applicable there. See, u is equal to f of xy. So that xy you can write as r.
Okay.
Okay.
Yes, sir. Huh.
Yeah. Now you differentiate it with respect to x. So what it will be?
Sir, then also y is constant, and then it would be y only.
Yeah. So this da by x will be y, isn't it? And this will be du by dr, which you can write that write as u dash.
Sir, could you repeat that?
U is equal to f of xy. In place of r, there is xy, right?
Yes, sir.
Okay. Now I am substituting that xy as r. Now you
Okay, sir.
differentiate it with respect to x.
Okay.
Okay. So what it will be? Du by dr and differentiation of r with respect to x. So r is
Okay.
xy. R is xy, right?
Yes, sir.
So what is derivative of xy with respect to x?
Y.
Y. So that's why there was y. And then du by dr you can write as u dash, no?
Yes, sir.
Ordinary
Yes, sir.
derivative. Yeah. That's what I was saying.
Oh, understood. Understood, sir. Understood. Thank you, sir.
Yeah. Okay.
Sir, can you show that table, the flow one? Yes. Thank you, sir.
Yeah. May I stop sharing? May I stop sharing the screen?
Yes, sir.
Okay.